Hello everyone, welcome to my next video on convolution code. Here we will see how to develop a code tree for the given example. So this is our given example that we are dealing with, wherein we had to design an encoder using a shift register having two stages. There were three modulo 2 adders which produced three different outputs based on the given generators. Okay. So this was seen in the earlier videos where we had designed the convolution code encoder for the given generators using the equations developed using the given generators, and we obtained the output V1, V2 and V3 by using these equations from the generators. This was seen in the earlier video. So this is the output that was obtained for the given data input. We had also seen how to develop the state diagram. So this was the state diagram that was developed in the earlier video. Then we saw how to develop the trellis diagram in the earlier video. This was also seen. We also saw how to obtain the code word from the state diagram and the trellis diagram when the data sequence is given. Okay. Now in this particular video, I will explain you how to develop a code tree for the given example of convolution code. As I had earlier mentioned, the code tree, trellis diagram and the state diagram are three different ways of representing the convolution code, and for the given problem, when we develop state diagram or trellis diagram or code tree, we can obtain the code word output for the given data sequence using this any one of these representation. So let us see how to obtain the code tree. So we will be using our same equations of V1, V2 and V3. It was earlier mentioned that the two states S1 and S2 we are representing by four different states by the values which S1 and S2 take. So when S1 and S2 are 0, 0, we call it as a state A, 0, 1 as state B, 1, 0 as state C and 1, 1 as state D. And this table of present state, next state and output was also explained in earlier video. We obtained this table, or we obtain output using V1, V2 and V3 equations, and we obtained the state diagram using a state table using the diagram that was shown for the encoder. So when the data input is, say for example 1, and if we are in current state A, which is 0, 0, when data 1 arrives, the next state would be state 1, 0 and the corresponding output will be 1, 1, 1. How do we obtain this 1, 1, 1? We obtain it using these equations. So V1 is equal to data XOR S2. So data is 1 and S2 is 0. Present state S2 is 0 and we obtain 1 as V1. Similarly, V2 is data XOR S1. So data which is 1 XOR S1 which is 0. So 1 XOR 0 we obtain 1, and V3 is data XOR S1 XOR S2. So it is 1 XOR 0 XOR 0. So we again get V3 as 1. So for data 1, when the present state is 0, 0, that is when we are in state A, the next state is state C and the corresponding output is 1, 1, 1. This was seen in the earlier video. Now let us draw the code tree. So this is the code tree for the given example. I will explain you how this is obtained. So for designing the code tree, we will always start with state A. Okay, we always are in state A, and when we are in state A, if 0 arrives, we go upwards, and if 1 arrives, we go downwards. So let us start with state A. When we are in state A and if 0 arrives, we go upwards, and what is the next state? Let us refer to this table. When the data is 0, data 0 arrives, we are in state A. The next state is state A itself and the corresponding output is 0, 0, 0. So we are in state A, input 0 arrives, we go upwards, the next state is state A and the corresponding output is 0, 0, 0. Now when we are in state A and if input 1 arrives, when input 1 arrives, if you look at this table, the next state is 1 0, which is state C, and the corresponding output is 1 1 1. So when we are in state A and input 1 arrives, we go downwards and the next state is state C, corresponding output is 1 1 1. Now here when we are in state C, again let us look at when data 0 arrives, where do we go? So when data 0 arrives, we go upwards. The next state, when we are in state C, here we are in state C. When data 0 arrives, the next state is state B and the corresponding output is 0 1 1. So we are in state C. Data 0 arrives, we go upwards. The next state is state B and the corresponding output is 0 1 1. Similarly, when we are in state C and when input 1 arrives, we should go downwards. Okay. The next state is state D and the corresponding output is 1 0 0, which can be seen here in this row. Okay. Now again when we are in state A, same thing will repeat. We go upwards. If 0 arrives, we come downwards. If 1 arrives, and we can get the corresponding next state and output using this table. So similarly, for all the states B, C and D, we should create this tree. It looks like a tree, branches of tree. That is why it is called as a code tree. I hope you've understood how to create the code tree. Now let us take our example wherein the data sequence was given and we have to obtain the output using the code tree. So this is our developed code tree. For the given data sequence, let us obtain the code word. So the first bit is 1. First bit in the data input is 1. We always start from state A. State A is because our S1 and S2 is 0 0 or initialized as 0 0. So we start with state A. Now our input is 1. So where should we go? We should go down because for input 1 we go downwards. If input is 0 we go upwards. So input is 1, first bit is 1, we go downwards, we go down. Okay, when we are in state A and if input 1 arrives, our next state is state C and the corresponding output is 1 1 1. So output corresponding to bit 1 is 1 1 1. Now we are in state C. Now when we are in state C, what is our second bit? Our second bit is 0. So when 0 arrives, we are in state C, we go upwards. The next state is state B and the corresponding output is 0 1 1. We are in state B. The third bit 0 arrives. So again we go upwards. The next state is state A and the corresponding output is 1 0 1. Now we are in state A and the fourth bit 1 arrives. Where do we go? We go downwards. The next state is state C and the corresponding output is 1 1 1. Similarly, we can obtain output for all the remaining bits in the data input as given here. So this is how we can obtain the code word from the code tree when the given data sequence is given. Alright, I hope you have understood. Now how many branches of the tree you will draw here? Branches of this tree you will draw here. It depends on how many bits we have in the input. So here we have 7 bits in the input. So at least 8 stages in these branches we need to draw. Thank you very much for listening.